Hey, what's going on everybody? It's Caleb and welcome to your video on API concepts, design, and architecture. I'm really excited for this because this is the start of a series of videos on application development, backend development, API development. We're going to talk about a lot of concepts, but we're also going to follow up with hands-on exercises and building out applications. So first thing I wanted to mention is you'll want to check for the playlist link so you can watch through all of these videos. Now this is a pretty long one. It's going to set the foundation. So there's a couple of things I want to get out of the way at the beginning. So I already mentioned the playlist, but I also want to mention the notes. I have extensive notes for this lesson and some of the upcoming lessons as well. So you will want to check that out. I have a link down below. So those notes act as a companion for these lessons. It'll have everything we're talking about, different code examples, references, and additional information that'll go along really well with these lessons. The other major thing is that some of these lessons will be concepts, some of them will be hands-on. You definitely want to follow up the concepts with hands-on material so you can solidify what we're talking about here. It's very critical that you follow along and actually build APIs so you know how to take what we're talking about here and apply it to the real world. And then the last thing, this isn't really an advanced series, but we're not going to start from the absolute beginning. So we'll introduce APIs without much prior knowledge, but if you need additional computer science principles, I have a fundamentals course, which I'll have a link down to below. This is not mandatory, but if you find that the material here is going a bit fast, I'd recommend you go through that first. Oh, and one last thing, timestamps. We're going to cover a lot of information, so you'll want to use the timestamps available on the timeline or in the description to jump to whatever section you need. This will be handy if you want to reference certain sections later. Or if you don't get through the full lesson in one go, you can jump back to where you left off. So a while ago here on YouTube, I did a REST APIs and 1 hour video, and I think this was a pretty good introduction, but this video's focus is going to be a bit different. First, we're going to go in more depth. We'll cover the same material with a lot of additional information and cover more material in this lesson because this is going to be dedicated to just all of the API concepts you need to know to be a software engineer. We'll talk about the different types of APIs. You might be coming here looking for REST API information, which is the majority of what we're going to talk about, but there are other API types as well. So we'll talk about how REST APIs are different than these other types. Additionally, we're going to bring in more system design concepts. So this gets into a little bit more of dealing with different servers and how to architect your API in a way that it can be scalable. So we want to build scalable systems that can support many, many users. So if you're just getting started, some of these things you might not worry about because you're just trying to build your first API. We're going to do that, but then we're going to go deeper and talk about more stuff you should know. We'll also talk about pagination, authentication, versioning, and various other intermediate and advanced topics when it comes to building out applications. So I'm very excited for this video. Consider this to be the foundation that you're going to build the rest of your knowledge on when it comes to application development and APIs. So I want to introduce you to everything you need to be successful. So we're going to cover a lot of different things in this lesson. By the end of this video, you're not going to be an expert on everything, but you'll have a much better idea of everything you should know, and we'll continue to discuss all of those different topics in future lessons. So let's first start talking about what an API is, what it stands for. So this stands for Application Programming Interface. And this allows us to build applications that talk to each other. So when you hear the term interface, you should think of the surface area of potential interactions for an app. So let's say we build this app here. This app might work with a database and do all these complex things. But we don't just give everybody access to the database. We give specific things that the user can do. For example, we could get some data or we could delete some data. And these different things we can do, that concept is called an interface. And it allows us to interface with other applications. So we might have a different app over here. And we can interact with app 1 from app 2 because app 1 has an API. So these two apps could be two completely different apps. For example, I might be building some calendar app. And I'm using Google Maps API, basically asking, hey, how long would it take to get to my appointment? And the API gives me back a response. So basically, I just enhanced the functionality of my app by using some other app's API. This is a very common structure. Another very common structure is instead of using a completely separate API, I might actually split my app out into backend, frontend. So logically the same product or same purpose, but two separate code bases. And this front end will just make API requests to my backend. This backend can then grab data from the database or make sure that whoever's asking for this information is authorized to ask for that information, so we're not just giving data out to anybody. And then once the backend does all the processing and whatnot, it sends the data back to the front end. The front end can then display it all pretty and cute on a web page. So this is the other major structure that you will see APIs for. In this situation, you can still think of these as two apps. We have a front end app and a back end app. They're just working together to provide a single product. So this is different than if I use some third-party API to enhance my app's capabilities. But both of these are possible. Doesn't really matter. The whole idea with an application programming interface is you can do whatever you want. Basically, we create an app and we expose different capabilities to the outside world to interact with our app. So that is the general idea around APIs. So this is what we're building, right? But there are actually different types. So these types of APIs, that's what I want to talk about now. The main one we're going to start working with is a REST API. So REST, or you might see RESTful, which is an API that follows REST principles. So that's probably the first thing you should become familiar with, but we're going to compare it to some of the other options out there. So let's talk about the types of APIs. And I'm going to talk about some of the most common ones, but there are other ones, I'm sure. So the first one we just mentioned would be a REST API. REST stands for Representational State Transfer, so it's some way to transfer state between apps. REST will use HTTP, so we'll be able to do this inside of a browser, and it works with JSON. JSON is an object notation, so this describes how we structure the data that we send over the line. Now, another one you might hear is SOAP. Now, I never use SOAP. My temptation to make some stupid joke about real-world SOAP is unbearable. This is an alternative to REST. This was used a lot more in earlier applications, so you might see this for legacy systems or enterprise systems. A big difference with these SOAP APIs is that they use XML, which is, you can imagine JSON, but 10 times more annoying and difficult to work with. Then you have XML. So if you're building a new system, I wouldn't use SOAP, but you should definitely be familiar with it, at least an idea. So if you do come across a SOAP API, you're not like, oh, what's this? That'll be important if you're building a new system that integrates with an old system. That old system might not have a REST API and you might need to use SOAP. Even though you're building a new system, the interaction with the old system, you need to adhere to the API of the old system. So say this is the old system, you might be making new upgrades, and instead of completely replacing the old, you might just make a new app that integrates with the old app, providing new features or new interfaces for users. But for this, you might need to use whatever the old app uses for interaction. So that might be a SOAP API. Next up, we have GraphQL. Now, if you're familiar with databases, you might be familiar with SQL, and this is structured query language. GraphQL works in a very similar way, but it's not to interact with a database directly. Rather, it's to interact with a backend. So in this situation, instead of exposing multiple endpoints, this would be the traditional REST approach. What we'll do instead is we'll just create a backend. That is a very pretty backend that has one GraphQL endpoint that the front end can connect to, or the other app can connect to. And then the front end here does the decisions on what it wants. So you can think of it as the front end providing a query to the back end, and then the back end provides the appropriate response. So this is a really common thing. Usually I would recommend people learn this. So if you already are familiar with REST, you should probably get some experience with GraphQL. However, if you're brand new, I would recommend first learning REST. Next up, we have gRPC. Now you may have heard of RPC before, which is Remote Procedure Call. You can think of this as a way to execute things on the back end. But when we prefix it with G, this is a specific protocol, the Google RPC protocol. Now, many people are going to say that this G stands for Google. However, I think officially this stands for gRPC Remote Procedure Call. So it's just a recursive acronym. You'll see this quite commonly in different technologies. But ultimately, when you see gRPC, you can think Google Remote Procedure Call. And this is a specific type of API that uses something called protocol buffers or protobufs. So instead of XML or JSON, we'll have protocol buffers. So this is an approach to serializing data that's very effective. It reduces the size of the data as much as possible, allowing for very fast transfers between apps. This is really common for microservice architectures. So let's say instead of just having a front end and a back end, you might have all these different components that interact with each other. And all of these work together to provide the architecture for some app. This generally is called a microservice architecture, and using protobufs is pretty common for this, for that cross-app communication. Although not required, you could just use a REST API. So with this, you will have files that are of the .prototype, not prototype, prototype, and these define a structure for the types. So every single app can use these proto files to establish the structure of the data in their individual apps, whatever language that might be. So this is really great working across multiple different languages. We can define all of the types with these .proto files, and there's ways to transfer from a proto file into a certain type for whatever language you're working in. Now, I would say those are the main four you should be familiar with. You can also use things like WebSockets to interact between apps. So you can build a WebSocket API. And a WebSocket is a bidirectional channel to communicate. So if we have a backend and a front end, or two apps, they don't have to be back end, front end. We typically, with a REST API, will make a request to the backend, and then the backend gives a response. But with WebSockets, the backend can also send data directly to the front end without a request. Basically, the way this works is the front end opens a connection, and then that connection is maintained, and the communication can then happen from either direction as long as that connection is maintained. This is really common for real-time applications. So if something happens on the back end and we need to immediately tell the front end, then you could say this is a real-time app. For example, a communications app, such as chat or notifications, and so forth. Anything where the communication is initialized from the backend. But do keep in mind that the front end can also send data to the backend as well. So here are some of the other types of APIs. You can look up others if you want to know more information. These are some of the things I'm hoping to cover here in this playlist or on YouTube. So if you're interested in building some of these things, you'll definitely want to hit that subscribe button, follow along for the journey. And now what I want to do for the rest of this video is zoom in on this one here. REST APIs, or as I mentioned, you might see RESTful APIs. Once you have this down, you should be pretty competent in cross-app communication, and then picking up these others is going to be a whole lot easier because you understand the principles. Now, the actual way you do it is going to be different. So there's some stuff we're going to talk about that's specific to RESTful APIs. So specifically, we're going to have different methods we're going to talk about. We're going to have a variety of endpoints. We're going to have status codes, response codes, and we're going to be working with JSON data. So if you're not familiar with JSON, it's really, really simple. I'll show you a very basic example right here, right now. Right at this moment. I'm not going to delay. I'm just going to show it to you, okay? It's going to be right here. So JSON stands for JavaScript Object Notation. It looks very similar to an object in JavaScript. If you haven't used JavaScript though, it's no big deal. Basically, you're going to open the object with a curly brace. Then you're going to have a series of attributes. These will be quoted, such as name, and then a colon, and then the value, and then a comma, and then another attribute quoted, and then a value such as 30. In this case, it's not quoted. This supports different types here. So we can use a string, which we showed with Caleb. We could use a number. We can use a Boolean, true or false. We can have nested objects. That's an important thing here. We can structure objects inside of other objects. And we can have arrays. I think we can also have null as well, which you can count if you want. So if you have an attribute and you specifically want to say there's no value for that attribute, you can use null. Notice that there's no quotes here. That would be a string containing null. It's just null, the keyword. Now, if you're coming from JavaScript, you might notice some similarities, but within JavaScript code, you don't have to quote the attributes, and you can also use different types inside of an object within JavaScript. So for example, you could use a date or a function or undefined. These things are not supported in JSON, so it's not a one-to-one to JavaScript objects. So I wouldn't even really strongly associate this with JavaScript. I would just think of it as JSON with key value pairs surrounded by curly braces. Okay, so we have a pretty decent understanding of the structure of our data. How do we use this structure to build an API? What does a REST API look like? Well, it's some of the things we just mentioned. We'll have a method, for example, and these are written in all caps. Get, this is an HTTP method. So REST API is built on top of the HTTP protocol. So with that, you'll have an HTTP method. Get is a very common one. This is used to retrieve data from a server. And when you go and visit a web page, you're actually making a GET request, even if you're not working with APIs directly. And then you'll typically have some resource. So resource, you can think of this as, here, let me give you a bunch of other abstract names. Entity, an item, or some database record. This is basically the thing that we are wanting to interact with. So an example of this would be users. And that would be something that might give us back that same JSON structure we saw earlier, where we have the person's name and their age. I'm going to go through the example of comments posted on a website. So this could be a social media, it could be whatever you want, anywhere that you can post a comment. So let's say you have a video and people can post comments below. We need a way to be able to retrieve this information from the backend, and we don't have direct access to the database. So it's going to look like this. We have the backend. The backend stores that data in a database. We make a request for comments, and then that backend formats the data as we need and gives it to us in JSON. Once we have this JSON data, we can work with it on the front end to format it and make it look nice to the user, which is how we end up with a web page with the post and then the comments below it. So that's the general workflow. Then when a user goes in here and maybe posts a new comment, this is going to follow that same pattern, but now it's going to make a request to the backend with a different method. So instead of a GET request, we're going to do a POST request. All right, at this point, you have a pretty decent idea of what a REST API looks like or how you interact with it. You have a method, you have some resource, and then you work with JSON. That's how you communicate back and forth. So how do you grow this to then a collection of different endpoints? So that's a word you should know. You can think of the endpoint as a combination of the method plus the path. The path here is basically a URL describing what resource you're trying to interact with or collection of that resource. So let's take a look at an example with comments. We're just going to write out all of the URL structures, and you can think of these as basically the different interaction points or interface to your API. So these will all probably be prefixed with slash. So you start with a slash, but you're going to have something before that slash, which will be whatever your base URL is, the backend API URL. So it might be something like mysite.com/API. And then it's pretty common to have some version in here. So you might be on V2 or you might be on V1, basically a way to create different API versions. Then you will have the resource. And then if you're working with a specific instance, so not just all of the comments, but one comment in particular, then you can pass in an ID. Now this is substituted in. So when you visit the web page, you're not going to actually put ID. You'll put in a value like 5 or 105 or whatever the ID is for the element, the resource you're trying to work with. So the way you describe that this is substituted in, you might see something like brackets ID, or you might see colon ID. The exact notation is irrelevant, and every framework is probably going to have a slightly different structure. But the idea is that we need to indicate somehow that the user provides in an ID to access that element. So for us, we're just going to use curly braces, ID. However, there are some architectural designs with the way you structure your URLs and your code around the resource. So in this situation, let's say we are working with comments. Do you work with comments directly, or do you always work with comments through something else, such as the actual post? So you might have post, the ID of that post, and then get the comments for that post. This is a different structure where you now think of comments as bucketed underneath a different resource, in this case, posts. And usually this is going to be plural. So posts, ID, comments. So we'll talk about some of these ideas of nesting data, as there are some alternatives where you can use URL parameters to query or filter data differently. So we'll look at that soon. But for now, let's go with this approach here where we are working with a parent resource. We access a specific post with an ID, and then we can grab all of the comments for that post. So let's write out some example endpoints. We'll start with the method. And because we'll often have the URL/API, potentially /v1 or v2, I'm not going to put that every single time. You can just think of that as copied on all of these. So all we'll have is /posts /ID /comments. So this is the endpoint for retrieving all of the comments on a specific post. So we have some video. This video has the ID of 1, 2, 3, and it has a series of comments down here. The API endpoint to retrieve this information would be posts 1, 2, 3, comments. So this is the URL you would use to access all of the comments for the post with the ID of 1, 2, 3. Now the next method we're going to look at is post. This is how you add data. Now don't be confused because we're talking about a resource, posts. This is referring to posts on some social media platform, like a video post. Then we also have post, which is an HTTP method. That means to create. That's usually used to add new data. So when we come up here and we say post, we're talking about the method. And we're going to create a new comment. So it'll be the same exact URL structure. The only change here is the method that we used. So the method is used to tell the server what we're trying to do. Because we're adding some new data, we will need to attach the comment data itself in the body. So when you make a request, you'll have headers and you'll have the body. So that's where the actual JSON goes. So when we get some hands-on practice with this, if you've never done this before, I'll show you exactly what I mean. So that's going to be important anytime we're adding new data, because the URL itself doesn't give enough information. It doesn't say what the comment we're actually posting says. So we need to include the actual comment content, and we do that in a separate section called the body. All right, so you have the video post, you have comments on here, and we know how to get them all, but there might be a specific comment, and when you create this comment, that comment is going to have its own ID. Let's just say it's 321. Well, to access this comment, if it has a unique ID, we don't need the parent ID. We don't need to know what the video ID is. So we can access this without the nesting of the post. So it'll look something like this. Get/comments/ID. So if we made that concrete, it would be /comments/321. And that'll give us the comment content. And most likely it would have the post ID as well as part of that data, so we could associate it with a certain post. So if we needed, we could use that to figure out what video it goes on. So let's just add some notes here. So this is to get all the post comments. Add a comment to a post, and then grab a specific comment. Next up, the next method we're going to learn about is put. This is used to replace or update some data. So if we're going to edit our comment, we can use a put request. Again, for all of these that are working with a specific comment, we don't need the parent post. So we can just say comments/ID. So notice these are the same URL, similar to get and post. The only thing differentiating them is the method used. So this will replace or update comment. Now there's another type of request we can make, which is a patch request, which works pretty similarly, but there's some key differences here that you need to understand. So the URL will be the same. This is going to partially update. So what that means is with patch, if you had some document and you had multiple things you wanted to change in it, with a patch, you could just select one of these things and change it. With a put request, you will take the entire information, make some changes, and send the entire information back. So you're basically replacing the document. It's going to be the same idea here with comments. If we're using a put request, we need to take the full comment, make the changes, and then send the full comment back. With patch, we can selectively change attributes of that comment. So this really only makes sense if a comment has multiple attributes. So I might have a comment ID, a post ID, the actual comment content. Maybe it's a Boolean whether this is a reply to somebody. Maybe there's a Boolean on whether it's a pinned comment. And basically with a patch, we could update any one of these attributes individually. But with a put, we're going to take all of the information. Again, we'll change some piece of it, and then we'll give the entire document back, replacing the old one. So logically, we're still updating the data. The ID is going to stay the same. But the way we're updating the content is by replacing it completely. So one very important thing about updates is that they should be idempotent. And this is a fancy word to basically say if you execute that update multiple times, the end result should be the same. If we replace the document 100 times with the same information, we still have the same end result. And that's exactly why this comment ID has to stay the same. Because if we were giving it a new ID, we're creating a different comment every single time. This is important for accidental resubmissions. we could submit and update multiple times. And that's not going to break anything. But if we did a creation, if we did a post multiple times, we're going to either get an error or accidentally create duplicate data. So a post is not supposed to be idempotent. Now, this attribute is something that you need to enforce in your code. So you can code these to do whatever you want. You could make a post delete data. You can make a get update data. That's all up to you on the back end. But these are standards and a specification for a reason. People adhere to these because you can have implicit meaning behind these words. So when we're talking about updating data, it should be known to be idempotent. So we're not going to be replacing the ID of the thing we're updating. Next up, we have delete. It's pretty tough to figure out what this one's going to do. Again, it's going to be the same path because we're referring to a specific comment. And that will remove the comment. Now I want to show you a couple more examples. What if we wanted to reply to a comment? In this situation, we would have a comment that in a way depends on another comment. So we would need to know information about the parent comment. Who are we replying to? So the way we would structure something like this would probably be a post because we're creating a new comment. And then we would do /comments /ID. And then we could have a new path such as reply. And this could reply to a comment. And the reason I wanted to write this one out is because I wanted to show you two possible different scenarios here. And either one is okay. So it's not like the way you do things is 100% set in stone. You can have design decisions about the way you structure your API. So what exactly am I talking about here? Well, we could now create a comment with this post, or we could create a comment with this post. Basically, we need to get the parent ID from somewhere. In this case, we're getting it from the URL. In the case of this post request, we're not providing the parent ID here, right? We're providing a parent video that the comment's going to go to, but we could still create a reply here if we wanted. It would just be passed in the body, so it might look something like this. The video was 1, 2, 3, and then the body would have the content of the comment, and it would have the parent ID. So both of these could work the same way. In this situation, we're passing the ID of the parent in the URL, 567, and this one we're passing the parent ID in the body. Either one of these are going to need some parent to grab the ID from. So the only major difference is how you want to structure the URLs and whether or not you want this to be nested under posts or not. In reality, if you're making a comment reply, it doesn't matter what post it's on because that parent is unique. Basically, we have a comment 567 and we are creating a reply to it. We do not care what the parent post is. We only care about the comment we're replying to. Logically, it's going to get us the same result in the database. This one just has it unnecessarily nested under a post. Let's go with one more example, which would be to get a comments replies. So this might be at /comments /comment ID /replies. Same idea here. We don't really care about what post it's on. All we need is the ID of the comment we're replying to. So one quick comment that I wanted to add here, I would consider each one of these a different endpoint. So we have 8 different endpoints here. There might be some conflicting vocabulary that you run into. So for example, we could consider all 4 of these to be the same endpoint with the same URL, and then just have 4 different method options. But I don't think that makes as much sense because these, in my opinion, are unique interaction points of our app. So even though they're sharing a path, logically I see them as different endpoints. I wouldn't get too caught up in the vocabulary for this, but that's just how I tend to think about it. But what you can say is you definitely have one path with 4 different methods. So all of these in code could point to a single function, or it could instead go to 4 individual functions. This is a design decision that is irrelevant from the interface of the API. The way you work with the API is exactly the same. So all of this stuff gets into how you structure the code, and I wouldn't worry too much about that right now. It's just the way you structure your code. Do you have one function and then you check what the request type is, the method? Or do you have 4 different functions, each one being associated with the combination of the method and the URL for unique destinations? So when we get into implementation, we'll see the differences here. But for now, I would just focus on what the API allows us to do. So this is our full interface of how we could interact with comments. We can continue to think of different ways of how we might retrieve comments. For example, we might want all of the comments from a certain user. In that situation, it would look something like this. Get /user /ID, and this ID always refers to whatever it is that came before it, so the user ID, and then we could have comments. We're still working with comments, but we're basically shifting the way we're thinking about comments. Instead of associating them under a post, we're now thinking of them by user. So we're changing the bucketing. For a simple API, you probably don't worry too much about it. Maybe we have just this many ways to access comments. But for a complex API, there might be a large variety of different ways to retrieve comments. And remembering the nesting and the structure for this can get complicated. I'd say starting out, I prefer this structure, but I want to share an alternative, which is basically the comparison of nested data versus filtering. And this would be filtering just a large singular collection. So let's go through examples showing the differences of these, because when you're designing your API, you want to know how you're structuring the API endpoints. This is also going to get into different ways of passing data. So this is part of the path, but you can also use URL parameters, query parameters. We're going to look at those as well. So we've already talked about nested data. Basically, when we want to access some entity, but relative to a collection such as the post, we can structure our URL like this. And I don't know why I didn't finish writing comments, but it's going to look something like that. Now for filtering, we just consider having one giant bucket of all the comments, and then we provide additional information to say which of those comments we care about. So we have our giant collection of all of our comments, and then we say question mark, then some attribute such as the post ID, and then we set that to whatever the ID is we are looking for the post. So this concept with the question mark, this is called a query parameter, or you might hear URL parameter. It's slightly different than putting it in the path. So you can see here we don't use a question mark here, but functionally it can be used to achieve the same results, which is changing the data that we access. So we'll talk more about the differences between using a query parameter and using the path in a moment, but for the sake of this example, it doesn't matter. All you really need to know is that we can provide some attribute to filter. So now we go from all of these comments to just a select few that we care about. And this would be based off of the post ID, whatever that value might be. In the notes, I have some additional links you can do for reading on this, but I'm just going to summarize when you might want to do each one of these. So for relatively simple data, or another way you can think about this would be few access patterns. So you're not going to be changing the way you're accessing comments in a bunch of different ways. For example, you might just have accessing the comments by the post and by the user. In that situation, using nested data and going with this approach is pretty clean. But if the different ways you need to access the data is vast, it can be pretty complex to create endpoints for all the different possibilities. Instead, you could just group all that together into a single... Dude, I am hungry. Instead, you could just group everything together into a single endpoint and allow the user to filter what they're accessing by. So if you have complex that's a freaking tongue twister. So if you have complex access patterns, organizing those comments by a variety of different parents, Doing this across multiple different nestings can be very complicated and ugly, so you might just put it all in one and use query parameters. This choice can actually affect your code structure as well, because you might have code for posts, and code for users, and code for comments. And you basically have to decide where you're going to store the code, so there might be some jumping around. Or if you're working in this other pattern where you just provide in additional filtering, you can just put everything inside of a single location for comments, which can really simplify the code surface area. You don't have a bunch of places to jump around to or have to memorize some system or architecture. So which one do you choose? All right, my personal opinion here is I prefer this structure where we access by some parent resource. So this is what I prefer. If you have a certain scenario where you're like, hey, this is just not going to work for what I'm trying to do, then you could consider this approach. This approach would work well if you needed to allow for a bunch of different filtering capabilities. Now let's move on to how we pass data to the backend. So we've talked about a few different options here. We've talked about query parameters. We've talked about passing data in the path, and we've also talked about passing data in the request body. So these are the three main ways of passing data to the server. When do you use which? So let's first take a look at these two, because they have something in common. They both go in the URL. So typically we'll use a path if we're using it to identify some data that we're referring to. So we have the resource, but we're not just talking about a full collection of resources. We want to access a specific resource. So very commonly, the path is going to be an ID. So IDs usually passed in the path. And in that situation, you don't use a question mark or an and sign. You just say something like /123. And this is basically a unique page or value you're referring to. So for example, an exact comment. So the path is used for identifying. Query parameters are usually optional, and they're usually used for filtering. So if you don't provide them, it's just going to default to everything. So filtering and sorting is going to be done with a query parameter. So if we change the ID, we change the actual item we're looking at. If we change the query parameter, it's still the same path. You can think of it as the same endpoint. It's just going to change the filtering or sort. So that's really important to understand. Another thing is that with query parameters, you can stack multiple in a row. You can do that with the path as well, but there's typically going to be additional nesting. So for example, we could have comments, then the comment ID, then we could have replies, and then we could have the reply ID, or whatever it may be. I'm just kind of making this up as I go, but in this situation, we basically work our way up the path to get to the original entity that we're discussing. And we're providing multiple IDs, so they have unique names. Changing either of these is going to change that exact comment we're talking about. Whereas for query parameters, we might have something like cars, question mark, color is blue, brand is Lambo, and sort is ascending. And we could be more specific, we could say price ascending. And then the backend could still access all of these values and use that to adjust the query to the database. You will also see this similar structure for paged data, so pagination. So you might see page 5, or you might see a limit on how many you're trying to retrieve, and so forth. We'll definitely get into that. So that's query parameters and the path. Both of these are provided in the URL. And generally, you do not want to do this for anything sensitive. Because think about it. If you have a URL, that's a URL you could share with somebody. It's something that's going to be saved in your browser history. You could favorite it or whatever it might be. It's a unique link. So if something's private in that link, it's very easily going to be exposed and it's bad for security. So if there's anything sensitive, it always goes in the body. So for example, let's say we had a /register. You could do it the bad way, which would be /register. And then we'll provide a username and we'll provide a pass. And this is a unique URL that has my username and password that I'm trying to use for registering embedded in that URL. This is bad. Instead, we should just have register, and then we'll have, as part of that request, a body, which will then have those attributes. So we'll have a username and a password. And that will be formatted in JSON, so it looks something like this. So this is the proper way to do it. Anything sensitive goes in the body. This is also related to if you've ever been on a website and they have some form and you hit submit, and then maybe something doesn't work quite right, so you hit the refresh button and it'll say something like confirm form resubmission. Basically, it's making a request, a post request. So forms will use post with all of the data that you typed in as part of that body for that request. So when it's asking you if you want to resubmit that form, it's basically saying, hey, do you want me to send another post request to the backend? We already did it once. But yeah, translation, what does that mean for you? It means anytime we have an HTML form, it's going to use the post request type for that submission. And that means any of that data does not get added into the URL. However, if you're not doing anything sensitive and you just want to give the user the ability to sort and filter, you can make those dropdowns and make the request to the backend with that in the URL. So with this in mind, let's look at what a full request might look like. You might have post /API/users. So this would be creating a new user. You could also have it be /register. You'll have any other headers. So you'll often see content type. And this is how you basically say the notation being used for the request. And this will be applications/JSON. Then we'll skip down here. We'll open body. And then any attributes we want to send to the backend. So here is some example data, all within JSON. This is a pretty common structure you're going to see. So for example, if you're working with API testing tools, for example, curl or some of these other tools out there to make requests to APIs, and you're formatting the structure of the request, it might look something like this. So this is an example of a header, content type, really common one to specify JSON, but there are other headers you're going to become familiar with as well. And this is data that's passed with the request, but it's different than the body. You can think of headers as metadata, which is data about our data, describing how to interpret the data, for example. And we'll use headers for all kinds of different things. Now, last thing I'm going to touch on briefly, because we're going to dedicate a lot of the next lesson's material on this, that is status codes or response codes. So just like there are standard HTTP methods, get, post, put, all that stuff, there are status codes which are included with the response from the server. So we just looked at how to make a request, but the backend might give back a status code, for example, 201. This is just one example of a status code, and every single one of these codes has some implicit meaning. Now you, as the API developer, you can send back whatever status codes you want, but generally you'll follow conventions in a similar way you do with HTTP methods. So 201, this will have the text associated with it, which is created. And when a client sees this, it can interpret that message to mean, hey, we likely created a new resource. So this is a common response for a post request where we're creating a new value in the database. So there are a bunch of different codes in the 100 range to the 500 range, each one meaning something unique, but there are different categories. The big ones you should concern yourself with are at the 200 level, which are all kind of like, okay, things are working. 300s are redirects. 400s are client errors. and then 500 are server errors. So in the next lesson, we're going to look at more of these status codes and how you should interpret those from the client. What do you do if you get a certain status code? As well as the API developer, how to know which status codes to use in what scenarios. So that's what we're going to get to in the next lesson. As well as once you do all of this, we now have a fairly complex interface to work with our API. We need some way to describe this to other users. So this gets into the world of API documentation and specs. Since we're following some standards, maybe people can get an idea of how our API works without us even having to say anything. So this gets into the world of OpenAPI and various other things. So we're going to talk about all of that in the next lesson. So just so you have an idea of some of the things I have for the next couple of lessons, I'm really interested in talking about those status codes, API documentation and specs, proper API architecture for scalability. We're going to look at authentication at a high level, how it interacts with APIs, things like API keys and JWTs. We will also look at pagination and how we can transfer a lot of data to the end user in sections instead of just giving everything at once. That and so much more. So I'm super, super excited if you made it this far in the lesson. Really appreciate it. Hopefully it was really helpful. Again, just wanted to give you a reminder to check the playlist. The playlist is where you're going to find all of the good stuff and you can just watch it sequentially. Go through this material one lesson at a time, and I promise I'll help you become a much better software developer. So super excited. I know I've said that like 5 times, but it's just really awesome, and I'm really happy to be doing this. So thank you so much for watching. Check out the playlist. Check out the notes for this lesson and the upcoming lessons. I'll have a link down for that below. Check out the fundamentals course and my other courses available if you're interested. And with that, I will see you in the next lesson. Thank you so much. Peace out.